everybody, welcome to another video. Hope you're ready to flex those brain muscles because today we're going to do some polynomial long division. I already made a video just as a refresher on just normal long division if you want to click on that. I feel like it helps a little to at least remember a little bit how long division works so you can relate it to this because it is very similar. Okay, so let's go ahead and do this long division. So again, I have our vocabulary words we can use here, and we can call this the divisor. It's the same as just regular division. This is the divisor on bottom, and this is the dividend on top. And so the the dividend gets divided by the divisor. That's how I remember it. So the divisor kind of goes into the dividend is how I think of it. So our divisor is out here, and that's going into the dividend, x cubed minus 2x squared plus 5x plus 1. Now let's go ahead and start the process. So the way I think of it, because in regular long division you think of how many times does this go into this, and you kind of go piece by piece. And I think of it similar but just a little different. I think of what do you multiply x by to get x cubed. And in this polynomial long division, we're only concerned with the first term out here. So if this was a trinomial, we'd be concerned with the x squared, whatever the highest power term is, right? So this x, in this case, we're asking what do I multiply x by to get x cubed? That's simply x squared. So where do I put the x squared? I personally keep it right above this x squared, and I think of these as columns. This is an x squared column. This is the x cubed column. This is the x column, and this is the constant column, and it keeps me real organized when I keep it that way. So x times x squared gives me that x cubed. So I do the same process. I multiply back down, and I get x cubed. And then I multiply back down and I get plus 2x squared, right? And this is the little bit tricky part where students make mistakes, is that I have to subtract down. But really what I'm subtracting is minus this whole thing, right? So I got to do x cubed minus x cubed, which gives me 0. But then this is where students make mistakes. I got to do minus 2x squared minus 2x squared, so minus 4x squared, right? So just be careful with the subtraction, doing it down. Make sure you distribute the negative to both and you're subtracting. Okay, so what do we have now? We're asking ourselves this same question. What do I multiply x by to get negative 4x squared? That's simply negative 4x, and I'm going to put that in my x column, right? And then I do the same process, negative 4x squared, negative 8x. But what did I forget? I forgot one thing. I have to carry this 5x down, right? Same process as regular division. Whoops. Same process as regular division. This 5x comes down. Now I can subtract. So negative 4x squared minus negative 4x squared. That's plus 4x squared, and that's 0. And this should always be 0. That first thing you do should always be 0. So if it's not 0, you did something wrong. And then let's see, 5x minus negative 8x. So that's actually positive 13x. And then I can go ahead and bring down my 1 plus 1. And I'm going to do the same process. What do I multiply x by to get 13x? That's just 13. Multiply the 13 back out, and I get 13x plus 26. And now I subtract. I'm almost done. I'm going to get 0 here, and I'm going to get 1 minus 26, right? 1 minus 26, so negative 25. So this is actually my remainder. And anytime you have something here where it's less of a degree than this is like first degree. This doesn't even have x's, right? I can't multiply x by anything to get this negative 25, right? It won't go into it, however you want to think of it. Then this is the remainder, right? Same idea as with just normal division. So the remainder goes up here. And remember, we always put the remainder over the divisor, x plus 2, right? So this is our final answer. When you divide these two polynomials, you get this quotient. And if you wanted to check your answer, you can multiply this divisor back in, and you should get back to the dividend, but not really necessary. Just check your steps, make sure you did everything right. And let's do one more example. All right, last example for this video. We'll go ahead and work this out. Remember, we have our divisor, and that goes into the dividend. That's how I think of it, at least. The divisor is dividing into the dividend. So I have this x cubed minus 3x squared. And this is the reason I gave this example. That's a bad 3, I'm sorry. This is the reason I gave this example. is because there's a little trick you can do to make your life easier. Remember when I said we have x cubed, x squared, x column? In this case, we don't have an x here. So we can write that plus 5 here, but then we're missing our x column. What if we need an x column? And a lot of times it makes it a lot neater if you can write that plus 0x plus 5. And we'll see why when we start working this out. So that's the little trick. Whenever you have like a term that's missing in between the highest and lowest term, you kind of fill those in with zeros, and it makes it more organized, and it's you know, there's less room for error. It's harder to make mistakes, that sort of thing. So let's go ahead and start. What do we multiply x by to get x cubed? That's x squared. And then I'm going to come back down and multiply this out. X cubed minus 2x squared. And then I subtract down x cubed minus x cubed, that's 0. Negative 3x squared minus negative 2x squared. That's negative 3x squared plus 2x squared, which is just negative x squared. All right? Then I carry down my plus 0x. All right? Now what do? Same process. What do I multiply x by to get negative x squared? That's negative x. And this is the reason why I use this column. It's because the x ended up being here, right? So we kind of need like a placeholder. It just makes it a little more organized. So same process. Come down. Oh my gosh. Throwing markers. Negative x squared. Negative x times negative 2. That's positive 2x. And now when I subtract down, look what happens. Another reason why I need this x column. Negative x squared minus negative x squared, that's 0. 0x minus 2x, that's negative 2x, right? So now, one last step. The 5 comes down, plus 5. Now what do I multiply x by to get negative 2x? That's just negative 2. Negative 2, go back and multiply it through. I get negative 2x plus 4. Negative 2x minus negative 2x, that's 0. 5 minus 4, that's 1. So what I'm left with is plus 1 over the divisor, right? Always over the divisor. So this is a good example for why you always need those placeholders and why it helps and keeps you more organized. So hopefully these examples were good and helped you out if you were needing some more practice with polynomial long division. Questions, leave those below, comment, that sort of thing. Like and subscribe if you enjoyed it and if you want to support me, and keep making those brain gains. See you next time.